So I work on small modification. I add some isothermalizer plates, and I use this. It's kind of a scissor and aluminium cans, quite easy to work with. And I see this as a funny art, like work with you can either work with knitting or do some sort of thermodynamic art. So actually the stroke is a bit of these two cans are a little bit low. It would be an ideal if the height of these two cooking ware was a bit higher for this kind of displacer. Now it tends to I couldn't adjust the stroke so much, so I have to have a low stroke. Otherwise the water level will be empty in these cooking ware, and then you will start to have a large dead volume, and that's not something you want. You should have now you have a nice plate you can do something with, and I enjoy to this is only one way to do it. You can do it in many different ways, of course, but this is one way. And actually if you put, you can shape it as you want and bend it, and it's quite nice. So if you put these plates very close to, let's say 2 millimeters, you will have a very good isothermalizer. And when you slow the frequency also, you have almost completely isothermal. You see, I have add one more pipe here, and the idea of this is actually I want to measure the pressure. So I put in this, a bit of this, and I could feel the force of the pressure on this should be on the water line. So the water level will be here somewhere, and hopefully I have water in here in a bowl. So I could feel the pressure with an like this. You can use, there is four force sensor in this, but you should actually, instead of this, you should use something like an Arduino and an HX711 for these sensors. Then you could log the pressure and sample it very fast, I guess. Hopefully at least 50 hertz or something, I hope. Then you can make a pressure volume diagram, and that make it possible to see what's happened inside. You can get out how well the engine is isothermal. You can see how much dead space you have, and you can of course see the power, the hydraulic power, and you exclude all the losses in the hydraulic with the check valves and the hydraulic losses. So you see the raw power of the hydraulics, and that's usual. But of course you see how well you can figure out a lot of things when you have a PV diagram of your engine. So you measure the pressure. I will measure the pressure with this, and then some way measure the volume change in the water. And then you get a lot more interesting data. One thing more, if you want to run the engine up to 100 degrees Celsius or so, you should definitely use this instead of using this material. I mean, these have little dead volume at the cutting edge. The open bubbles here actually have some little amount of dead space, and that's not good. Also, it's a bit heavier than this, so you should definitely use this if you choose to make a low temperature pump. I will adjust the frequency, slow down the frequency with a longer, thinner pipe. So I saw that the check valve was open before the displacer was hit the bottom, for example. And that's not the best thing. So there is some tunes you can do. This is just an example. Hope you enjoy to see this.